Here we have some perfect squares 4, 9, 49 and 324. These are called perfect squares because they have a root behind them which multiplies with itself to give us these numbers. For example, the square root of 4 is 2. The square root of 9 is 3, square root of 49 7 and of 324 is 18. Okay, now we have to find out whether this number is a perfect square or not. So we just have to see whether it is made up of any number which multiplies with itself to give us 3375. So we have to see the structure of number. We have to see by which number it is made up of. For that we need to open this number. Let's open this number through prime factorization method. So here I have opened this number and we got to know that 3375 is made up of these numbers. But we are not interested in these many numbers. We are interested in two numbers. Okay, and those two should be identical. Okay, just like 4 is made up of two identical numbers 2 and 2. 324 is made up of two identical numbers 18 and 18. Okay, so here also I just want to see those numbers. For that, to find out those number, to find out whether this number is made up of two identical numbers or not, we'll try dividing these numbers into two groups. Okay, so here 5 is twice, so I am segregating these into two groups. Then 3 is also twice, so I can write here 3 and here 3. But now I have 5 and 3. The moment I'll write 5 here and 3 here, so it actually makes these two numbers different. Till this point they were 15, but here it has become something else, 75, and this has become 45. So 3375 is actually not made up of two identical numbers. So that's which implies 3375 is not a perfect square. Now let's try one more number to find out whether it is a perfect square or not. Let's take the number 11025. For again, if I have to find out whether it is a perfect square or not, I have to open this number. So let's open it. So I have opened this number here and it is made up of these numbers. So 11025 is actually the result of product of these numbers. But we are interested in two identical numbers. Let's rearrange these numbers to see whether they can give us two identical numbers or not. So we have 3 twice, we can divide them into two equal groups. Then we have 5 also twice, so I can give it to first group also and the second group also. Then we have 7 2 times, we can give them to. Okay, so we got to know that this is 3 into 5 into 7, this is 3 into 5 into 7. So the answer will also gonna be same if these are same. Okay, so this is actually equals to 105 into 105. So we got to know that this is made up of two identical numbers 105 and 105. So now we can write that it is a perfect square, which implies 11025 is a perfect square. And its root is, so square root of, this is how we write 11025 is equals to 105. So this number itself 11025, this is equals to 105 into 105, but its root is equals to 105. There is a difference between this and this. This is a bigger number, this is a smaller number. From here also we can see 105 into 105 and it is only 105. So this is 11025. This is not 11025. This is square root of 11025. The moment you add square root here, you must write root here. Okay. Now this is how we find out whether a particular number is a perfect square or not. We just have to open the number. Just simply we have to open the number. Okay. The method is similar for perfect cube also. If somebody asks us that whether a particular number is a perfect cube or not, so what do we have to do? we just have to open the number and see whether we have a number which is multiplying with itself for 3 times or not. Just like here, 8 is made up of 2 into 2 into 2. So 2 is repeating 3 times itself in 8, and 3 is repeating 3 times itself in 27. Okay, and similarly 7 into 7 into 7. Here this is 343. So 343 is also a perfect cube because 7 into 7 into 7 is repeating itself 3 times. Okay, so if we have to find out whether a particular number is a perfect cube or not, we have the similar procedure. We have to open the number. After opening, it's this. Now we have to divide this into 3 parts to find out whether it is a perfect cube or not. Okay, we have to see, is there any number which is repeating itself 3 times? Okay, we have already opened the number. Let's see whether this number is a perfect cube or not. So let me do it here. Okay, so your 3375 is actually equals to 5 into 5 into 5 into 3 into 3 into 3. So here this is we can be divided into 3 groups or not. So here we have 3 5 times. The first group, second group, and third group. Now 3 is also 3 times. So here first group, second group, third group. Okay, we can shift their position. No, multiplication is commutative. We can multiply them in any order. So we are not doing anything wrong by shifting them. So I can happily put this equal to sign here. Now we are able to divide these numbers into 3 identical groups. Okay, if there would be an extra 2, so we won't be able to fit in anywhere. Okay, means we won't be able to divide all the prime factors into 3 identical groups, and in that case the number would not have been a perfect cube. But here we can see 3375 is actually made up of 15 into 15 into 15. So 3375 is a perfect cube. Okay, and if it is a perfect cube, so it has a root also, cube root. So cube root of 3375 is actually equals to 15. So this is how, by opening the number through prime factorization, we can find out whether a given number is a perfect square or not, or perfect cube or not. Thank you.